The question says 25.8 ml of 0.101 molar K2Cr2O7 is required to titrate 10.0 ml of a liquid iron supplement. Very interesting question. Calculate the concentration. Molarity of iron is to be calculated in vitamin solution. Okay, pay attention very carefully. K2Cr2O7 is a very strong oxidizing agent, and whenever it is coming in contact with iron, iron will undergo oxidation. Why? Because strong oxidizing agent is there. We can develop this equation. Okay, we have K2Cr2O7. K2Cr2O7 is there and it is reacting with iron. Iron is present in its common oxidation number, that is +2, and we have to show it undergoes oxidation reaction, then it will convert into +3 oxidation number. Increase in oxidation number is always oxidation reaction. And always keep in mind, in case of K2Cr2O7, it always converts into Cr3 plus. You can see our equation is ready. Very interesting part. Now you can see the data is given related to these two substances. Then we can equate their equivalence. You can see volume is given there in ml, so we use milliequivalence. Okay, number of milliequivalence of this substance is equal to number of milliequivalence of this substance. Okay, and based on the data provided, we apply the concept of milliequivalence. We have learned the formula of milliequivalence. Number of milliequivalence, let me write it. Number of milliequivalence is equal to molarity multiplied by volume in ml multiplied by n factor. N factor value can be calculated because equation is ready. Okay, let's calculate n factor value. Remaining data is given in the question. Okay, so first of all, we write down the oxidation numbers of same elements on both sides of the equation. 7 2 is 14 plus 2 is there, we got +12. 2 Cr is equal to +12. 1 Cr is present in +6 oxidation number. Others are monoatomic ions and their charge is equal to their oxidation number. Always balance the number of atoms before balancing the charge. How many Cr? 2. Other side, how many Cr? Only 1 multiplied by 2. Number of atoms are balanced. 1 Cr is present in +6 oxidation number, then 2 Cr will be present in +12 oxidation number. Very interesting. Other side, 1 Cr is +3, then 2 Cr will be present in +6 oxidation number. To calculate n factor value, find the difference in oxidation number. 12 minus 6 is equal to 6. N factor value is ready, that is 6. Okay. In case of iron, very easy part is there. 3 minus 2, find the difference. 3 minus 2 is equal to 1. Then we got n factor value is what? 1. So for iron we are getting n factor value. For iron Fe2 plus we are getting n factor value 1. Now we apply the concept. Number of milliequivalence of this potassium dichromate is equal to number of milliequivalence of Fe2 plus. Okay, so formula is written. Better if you want I can write. We have number of milliequivalence of K2Cr2O7 is equal to number of milliequivalence of Fe2 plus is there. Okay, formula I have written already. Formula is already written. Okay, molarity multiplied by volume in ml multiplied by n factor value. Let's plug in the value. First we have molarity. For K2Cr2O7, what is the molarity given here? You can see molarity 0.101 is there, multiplied by volume is given there 25.8 is there, and n factor next we have n factor. What is the n factor? 6 is there, is equal to other side number of moles, number of milliequivalence of Fe2 plus. So keep in mind, we have to calculate the concentration of iron. Okay, concentration is nothing but the molarity. Okay, concentration is nothing but the molarity, which we have to calculate. Molarity multiply by volume in ml. How much volume is given there? 10.0 multiplied by 10. And what is the n factor value? Next we have n factor for Fe2 plus is 1. Now we can simplify and calculate molarity. Very interesting part. Okay, so now we have 10 multiplied by molarity is equal to, if you multiply here it will be 0.606 multiplied by this is what? 25.8 is there. If you transfer 10 other side, we get 0.606 multiplied by 25.8 and divided by 10 is there. Okay, now we can divide. We get 0.606 multiplied by 2.58 is there, and if you multiply these two values you will get 1.56. You will get 1.56. D option is correct. The value which you will get, that is 1.56 molar there. This is the concentration we have. By using the concept of milliequivalence, we can easily answer this question.